Acceleration. Constant speed is easy to understand. However, almost nothing moves with constant speed for long. When the driver steps on the gas pedal, the speed of the car increases. When the driver brakes, the speed decreases. Even while using cruise control, the speed goes up and down as the car engine adjusts for hills. Another important concept in physics is acceleration. Is how we describe changes in speed or velocity. What happens if you coast down a long hill on a bicycle? At the top of the hill, you move slowly. As you go down the hill, you move faster and faster. You accelerate. Acceleration is the rate at which your velocity changes. If your speed increases by 1 meter per second each second, then your acceleration is 1 meter per second per second. Your acceleration depends on the steepness of the hill. If the hill is gradual incline, you have small acceleration, such as 1 meter per second. If the hill is steeper, your acceleration is greater, perhaps 2 meters per second. On the gradual hill, your speed increases 1 meter per second every second. On the steeper hill, it increases 2 meters per second every second. Acceleration is easy to spot on a speed versus time graph. If the speed changes over time, then there is acceleration. Acceleration causes the line to slope up on a speed versus time graph. The graph on the top shows constant speed. There is zero acceleration at constant speed because speed does not change. Acceleration are not the same thing. You can be moving non-zero speed and have no acceleration. Think cruise control. You can also be accelerating and not moving, thinking about dropping the car down the ramp. In the instant you release it, the car has zero speed because it is not moving yet, but it is accelerating because its speed is already changing. Acceleration is the change in speed divided by the change in time. Acceleration describes how quickly speed changes. High acceleration means speed changes rapidly. A powerful sports car can change its speed from 0 to 60 miles per hour in 5 seconds. The car has an acceleration of 12 miles per second. Low acceleration means speed changes slowly. A loaded garbage truck takes 15 seconds to get up to speed of 60 miles per hour. It has an acceleration of 4 miles per hour per second. To calculate acceleration, you divide the change in speed by the amount of time it takes for the change to happen. If the change in speed is meters per second and the time is in seconds, then the acceleration is in meters per second per second. An acceleration of 50 meters per second means that speed increases by 50 meters per second every second. An acceleration in meters per second is often written as meters per second squared. The steps below show you how to simplify the fraction in meters per second to get meters per second squared. Saying second squared is just a math shorthand way of talking. It is better to think about acceleration in units of seconds speed change per second. Speed versus time graph is useful for showing how the speed of a moving object changes over time. Think about a car moving on a straight line. If the line on the graph is horizontal, then the car is moving at a constant speed, figure 318. The slope in the middle graph shows increasing speed. The downward slope in the bottom graph tells you the speed is decreasing. The word acceleration is used for any change in speed, up or down. Like velocity, acceleration can be positive or negative. Positive acceleration adds more speed each second. Things get faster. Negative acceleration subtracts speed each second. Things get slower. People sometimes use the word deceleration to describe slowing down. The position versus time graph is a curve when there is acceleration. Think about a car that is accelerating, speeding up. Its speed increases each second. That means it covers more distance each second. The position versus time graph gets steeper with each second. The opposite happens when a car is slowing down. The speed decreases so the car covers less distance each second. The speed versus time graph gets shallower with time, becoming flat when this car is stopped. The object is in free fall if it is accelerating due to the force of gravity and no other forces are acting on it. A drop ball is in free fall from the instant it leaves your hand until it reaches the ground. A ball thrown upward is also in free fall after it leaves your hand. Although you might not describe the ball as falling, it is still in free fall. Birds, helicopters, and airplanes are not normally in free fall because forces other than gravity act on them. Objects in free fall on Earth accelerate downward, increasing their speed by 9.8 meters per second every second. The value 9.8 meters per second squared is called the acceleration due to gravity. The small letter g is used to represent its value. When you see the letter g in physics questions, you can substitute the value, 9.8 meters per second squared. The speed versus time graph below is for a ball in free fall. Because the graph is a straight line, the speed increases by the same amount each second. This means the ball has constant acceleration. Make sure you do not confuse constant speed with constant acceleration. Constant acceleration means an object's speed changes by the same amount each second. Acceleration and direction. If an object's acceleration is 0, the object can only move at a constant speed in a straight line or be stopped. A car driving around a curve at a constant speed is accelerating in the physics sense because it changes direction. Acceleration occurs whenever there is a change in speed, direction, or both. What do we mean by a change in direction? Consider a car traveling east. Its velocity is drawn as an arrow pointing east. Now suppose the car turns southward a little. Its velocity vector has a new direction. When drawing velocity vectors, the length represents the speed. A 2 centimeter arrow stands for 10 meters per second or 22 miles per hour. A 4 centimeter arrow is 20 meters per second, and so on. On this scale, each centimeter stands for 5 meters per second. You can find the change in velocity by measuring the length of the arrow that goes from the old velocity vector to the new one. The change in velocity is the small pink arrow that connects the old velocity and the new velocity. The arrow represents the difference in velocity before and after the turn. The change vector is 1 centimeter long, which equals 5 meters per second. Notice the speed is the same before and after the turn. However, the change in direction is a sideways change of velocity. This change is caused by sideways acceleration. Motion is caused by sideways accelerations. Like velocity, acceleration has direction and is a vector. Sideways accelerations cause velocities to change direction, which results in turning. Turns create curved motion. As an example of curved motion, imagine a soccer ball kicked into the air. The ball starts with a velocity vector at an upward angle, figure 321. Gravity accelerates the ball downward as it flies. The acceleration of gravity bends the velocity vector more toward the ground during each second the ball is in the air. Near the end of the motion, the ball's velocity is angled down toward the ground. The path of the ball makes a bowl-shaped curve called a parabola. A soccer ball is an example of a projectile. A projectile is an object moving under the influence of only gravity. The action of gravity is to constantly turn the velocity vector more and more downward. Flying objects, such as airplanes and birds, are not projectiles because they are affected by forces generated from their own power. Circular motion is another type of curved motion. An object in circular motion has a velocity vector that constantly changes direction. Whirling a ball around your head on a string. You have to pull the string to keep the ball moving in a circle. Your pull accelerates the ball toward you. That acceleration is what bends the ball's velocity into a circle with you at the center. Circular motion always has an acceleration that points toward the center of the circle. In fact, the direction of the acceleration changes constantly, so it always stays put toward the center of the circle. Here and answer the questions.